Continuing right along, we're on number 3, or C, number C, letter C, whichever you prefer. We're looking at sulfur dihydride here. So the electrons we have in this sulfur is going to have 6 electrons, and fluoride is going to have 7 each, so 14 total, so giving us 20. And we'll go ahead and draw it over here. Sulfur and fluorine. Go ahead and throw in all of the electrons that we have here. I don't know how many. We'll figure it out. 8, 10, 12, 14, 16, 18, 20. 20. Done. All right. For this one here, hydrogen is going to be bound to one of the oxygens. Sulfur is going to be central. We're going to surround that by 4 oxygens. I know I'm getting a little ahead of myself here. The hydrogens, we can put them on any of these. They're all the same. And it kind of looks like that. All right. So I did this a little backwards again. Sulfur's got 6. Oxygen is going to have 6 each. And I've got 4 of them, so 24. And hydrogen, I have 2 of them, so 2 total. So it looks like 32. Remember, hydrogen, you can't put any more on it. It can only hold 2. I've got a line there. It's done. Everybody else is going to have, well, who knows? We'll see. I'm going to surround them with 8 just to begin with. Sulfur I don't have to touch because it's got these 4 lines, which gives it 8. And then I just made sure that everybody else had 8 except for hydrogen. Let's see how many we have. 8 right here. 16, 24, 32. Done. That's how many we need. All right, let's move on over to chlorite. That's an ion. So this time I'll do it correctly. Chlorine has 7. Oxygen has 6 each, so 12. And then I've got 1 extra. So it looks like I've got 20 to put on here. And I'll put it over here this time. Chlorine is actually a central atom. It's less electronegative than oxygen. And we'll do the same thing, just throw a whole bunch on there. Give everybody an octet. And then we'll add them up. 2, 4, 6, 8, 10, 12, 14, 16, 18. That doesn't seem right. Let's try this again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I can add. So 20 on there. Don't forget to put the brackets and the -1. All right, one more we'll do here. Nitrogen has 7 electrons, so nitrogen has 7 total. All of the hydrogens, we have 3 of them. So that's going to be 3 total, and then I have oxygen. Oxygen has its 6, so it looks like 16. And then we'll draw it. Again, I didn't give myself a whole lot of space. I'll put it over here. We're going to have nitrogen as a central atom. It's the least electronegative. I have oxygen. And the way this is drawn, it kind of tells me that this nitrogen has 2, and then this oxygen is holding the hydrogen. So I'm going to kind of draw it over here with the oxygen hanging out here. These guys are holding on to this, and this oxygen is holding on to the hydrogen. Okay, so I need an extra pair of electrons on nitrogen. I'm just going to stick them there. And then I'll put these guys here. 2, 4, 6, 8, 10, 12, 14. Again, didn't seem to add this up right. 2, 4, 6, 8, 10, 12, 14. Something doesn't seem right. Oh, I know what I did wrong. Nitrogen. Let's figure this out. Nitrogen has how many? I wrote down 7. That was wrong. Right? It's element number 7, but that's not how many valence electrons it has. 1, 2, 3, 4, 5 valence electrons. Oops. So this will be a 5, and therefore this will be 14. So my drawing was correct, but my math was not. Okay, 47 is done. Let's take a look at 53. Do you want to do that one now? We'll hold off on that one because we have get some more notes in here that'll help us take a look at this one a little more easily. All right, do I have more notes around here? I do. Here we go. For this next part here, another piece of the puzzle is something called formal charges. So sometimes we have competing drawings, and it's like, well, which one should it be? And there's a method to figure out how we can go through here. Let's take a look. So we'll write some stuff down here first. Atoms may have different ways to assign electrons. So this is how we do it. First rule is all atoms should have the lowest formal charge. And that'll become a little more clear shortly. I'm not going to talk about that yet. Next, any potential negative charge, more electrons than it should have, those should be assigned to the more electronegative atom. Those will go to the more electronegative atom. And a couple examples here. We've got nitrogen, carbon, and sulfur. And there's a charge on them, so I'll come to that in a second. I'm going to write this 3 times to kind of get it set up. If we were in class, I would give you a little more time to fool around with this yourself, but I'm going to just kind of speed through here. It's got a charge of -1. Based on the total number of electrons we have in here, nitrogen brings in 5 total. Carbon brings in 4. Sulfur brings in 6. I'm going to make 4 little tables here. Well, actually, the way I'm going to set this to start up here is I'm going to say, okay, how many different ways can we put this together? I'm going to show you what those would look like right now. Let me pull this up a little bit so you can see this more clearly. This is one way we could draw this out. If, again, you were drawing these all out yourself, another way might be this one. And a third one, looks like I got a dot up here. I want to get rid of that, would be this one, which is almost a mirror image of the one on the far left. So these are the 3 ways it could be drawn. And again, I can say which one of these is proper, which is the best drawing based on these formal charges. To catalog this, I would ask you to go through and figure out how many valence electrons do these guys all bring into the party. And nitrogen, as I mentioned earlier, brings in 5, carbon brings in 4, sulfur brings in 6. And that's going to be the same each time. But now, how many, based on our drawings here, did you assign to each one? Well, in this case, 2, 4, 6, half of this, 7. So in this drawing, I assigned 7 electrons to nitrogen. Carbon had 4, 1, 2, 3, 4, half of a line. So because it's a pair. And for sulfur here, it brought in 5. 1, 2, 3, 4, 5. And then I'll do the same thing with these guys just to speed this along. I'm going to put the numbers in. And again, counting the dots and splitting the lines to give everyone the right amount. Now looking at this, based on the difference between the number of valence electrons they brought and the assigned electrons they have, that's going to give us a number down here. So we'll quickly go ahead and put these in based on the difference. And the reason we're doing subtraction is because these things are negative electrons. So it should only have 5, but it has 7 electrons. So it's holding a -2 charge, looking at electronegativities. So it's going to rule number 2. First of all, atoms should have the lowest formal charge. So ideally, we'd like these guys to have zeros. Well, this one has a real disparity of electrons. And again, based on electrons kind of moving through, it's going to kind of balance out as close to zero as we can get because positives attract negatives and it's going to balance. So you're probably going to be going more towards zero. So this one is probably not our best bet. So now we're looking at these two. We're looking at 0.2 as well. Any negative charge, there they are, should be assigned to the more electronegative atom. My choices are nitrogen or sulfur. Looking at the periodic table, nitrogen and sulfur, which one is more electronegative? And if you had numbers in front of you, you would see that nitrogen is the more electronegative atom. So this is the preferred drawing based upon formal charges. So again, you could draw it 3 different ways, but nitrogen being more electronegative, able to attract electrons better than sulfur, is going to say this is going to be our primary structure, not this one or that one. All right, good place to end this lecture.